Okay, so sorry I was a few minutes late. I was finishing up a email. We had a student yell at a teacher. It's funny. Just as an FYI, if you're ever trying to get something good out of a teacher, like have them give you the benefit of the doubt, you typically don't want to get in a fight with them. Kind of especially not, and they also did it in email, so it's like there's a record. So it was kind of funny. So I was apologizing for people. All right. So in any case, last time we were talking about some of these web technologies. And we were kind of talking about how the client-server model tends to work for web programming languages. So we have our web browser. So, like Apache, or not Apache, I'm sorry, Chrome or Safari or Internet Explorer, which they're getting rid of, right?
Yeah.
Internet Explorer is dying. Firefox, that's actually kind of interesting that Internet Explorer is actually finally going away. Yeah, but I mean, I think it's still the most used browser. Well, I mean, when grandma opens up her, gets in her computer, how do you get to the internet? You double click on the blue E. That's where the internet lives. So, I'm just surprised that that they're getting rid of it, especially since there was huge lawsuits about Internet Explorer historically. That was probably one of the big reasons why Bill Gates originally stepped down as CEO of Microsoft was because they were sued in the antitrust thing about Microsoft shouldn't be able to ship their operating system with Internet Explorer being such an important part of the operating system, like encapsulated in the operating system. They said it was a monopoly. That always seemed weird to me. They lost that. Shouldn't a company be able to ship their own software with their own software in it? But that goes to show that if you become too popular and you start acting like a monopoly, that people start limiting you to package your own products together. So who knows? But in any case, we were talking about this model. So whatever your web browser is, that's your client side, and web browsers speak HTML and JavaScript. That's the languages our web browsers speak, and they can interpret that and make it look like pretty pictures and some dynamic stuff on the client side. The server side might be a program like Apache, or if it's a Windows server instead of a Unix server. The common one is something called IIS, Internet Information Server. That's Microsoft's version of Apache, if you will. That's their web server. Okay? And so the idea here would be that the client makes a request, www.google.com, sends that request to the server then processes that request and sends the result back. Typically is HTML and JavaScript. If, on the other hand, you're doing something like logging in to like Amazon.com or something where you have a web form and you're sending a username and password or doing something dynamic, you would submit that web form. It would send the request to the server. The server would see that you're processing this request maybe through login.php or login.perl or login.sh. We were talking about some of the older languages that were here. But modernly, it might be login.php. Then Apache knows it has to go and run that program. Okay, so there's going to be another program that runs on here. So we're going to have the PHP module, for example, that's part of Apache. And that PHP module will take that index.php file, or the login.php file rather, and run it. So this is a computer program, okay, that happens to be written in the language called PHP. So this program will run, and it'll take the username and password that the web browser sent over. It'll do any of the authentication crap. And then ultimately, this program will spit its output out. And that output will always be HTML/JavaScript. Okay, so the output of web programs is HTML and JavaScript. Okay, it's got to be in that format. Why? Because it's going to be sending it to a web browser, which knows how to deal with that format. All right, so all this is a computer program that happens to output in this format. All right, so this is the web architecture. This is how web works. Now, we were talking about the evolution of some of these languages to see how we got to where we are today. So in the early days, we had CGI, and that was, this little hook that would sit here on the web server, and it would say, oh, if you're calling something other than a plain Jane HTML file, we'll pass it over to the common gateway interface, which then knows how to call some programs that live on the actual Unix machine, that live on the operating system. So we'll call a shell script, or we'll call a Perl script, something that you wrote. Well, once PHP came out, which was web-centric, it was designed for the web, rather than having to use CGI directly, where now you have multiple products. So you have Apache talking to CGI, talking to Unix, which then talks to Perl. Now you have Apache, which talks to its own PHP module, which is basically a plugin for Apache, and does all that processing. So you've taken a lot of the extra steps out. Okay, so PHP was a language specifically designed for web stuff. Now, to throw this into the world of programming languages, if we go way back to the beginning here, when we were originally talking about, there were 3 kinds of programming languages: machine, low-level, high-level. PHP is a high-level language. 2 types of programming languages: an interpreted and compiled. Remember talking about that. Interpreted languages are languages that get processed while the program's running, so a little slower, so kind of like the president's giving a speech, and a German news station is going to interpret the speech for its viewers, and the guy's dragging behind the president by a couple of seconds because he's got to convert the English words into German, something like that. Whereas compiled languages run very quickly because that's like the news station getting the speech an hour before it started, and they're able to translate the entire speech into German before the news broadcast starts. Then it's fast, okay? PHP is an interpreted language. And something we're going to see here is we're going to start seeing when we get to a slide like this, that all these languages we originally talked about, these guys are all compiled languages. Okay, so these are all programming languages specifically created for building applications native for computers. So either running on the desktop, a laptop, or mobile device. Okay, but natively. That is not on the web, not running through a web browser. Okay? All of these guys will fit that category of high level, compiled, procedural or object oriented. So C is procedural, all the other ones are object oriented that came after that, and general purpose. Okay, so all these guys are, so this is a procedural language, all the rest of these are object-oriented languages. All right, if we want, we can throw Swift in here. Have you heard of Swift before? Swift is a language that Apple just came out with like about a year ago. And we're going to connect some dots with Swift here in a few minutes. All right, so we'll throw Swift in there. If we're going to kind of give an organizational thing here, we're going to say Objective-C and Objective-C 2.0 are up here. Java, we're going to say, is more advanced than these guys, and so is C#. So we're going to say Objective-C, even 2.0, is still fairly archaic. Kind of the punchline here is Apple did not do a whole lot to make their languages more modern, because Apple kind of has a captive audience, that people are already drinking the Kool-Aid. They don't care how cryptic the language might be. They're Apple programmers because they want to be Apple programmers. You might go back in time and decide, okay, in the early days of Microsoft versus Apple, there was a real competition there, but there really wasn't. I mean, Microsoft, it was kind of a slaughter. Microsoft was very, very dominant in computing back then, right? Apple had 2% of the computing population. Microsoft had 98%. Close, but Microsoft's certainly winning. So most developers were developers for Windows machines, for Microsoft machines. So these languages over here had to evolve, all right? These guys really didn't have to evolve because they had a captive audience. Those developers, they didn't care what the language looked like. They were going to always think it was superior to these guys over here because Apple had something to do with it. All right, but finally Apple came out with Swift about a year ago, and we're going to say Swift is actually more advanced than any of these languages over here, at least by a little bit. And in a few minutes, we're going to give you the punchline as to why they finally decided to come out with Swift. I mean, even today, we can say that people who are writing iPhone applications in Objective-C, a lot of them came over from this side because they can now make money on the app stores writing applications for the iPhone, right? Well, people can also write applications for Android using Java and make money that way too. I think the stuff has shown that you're more profitable on iPhone, but you might as well write for both and make money from both sides, right? It's kind of the punchline. And that's something where we're going to talk a little bit about today about cross-platform type tools. But in any case, people were already jumping over to Objective-C, so whether the language was modern enough or not, people learned it. I actually tend to like Objective-C. I think that it, from a teaching language perspective, when I teach Java, so when you guys take the 250 and the 300 class that's starting next semester, where we're learning Java in there, I go back to some of these older languages like Objective-C to show you some of the stuff Java's hiding from us. All right, so this becomes kind of and really the second half of the semester here, this starts. Up to this point, we've been using GameSalad, which hides everything from us, right? We just drag stuff in and we know that there's logic magic happening behind the scenes and stuff just happens or crashes, one of the two. But a lot's being hidden from us. When we make a jump next semester to Java, where we're actually writing a lot of syntax, we think that, oh, this is a huge leap. But there's actually a whole lot of the code, a whole lot of the syntax that we are not having to write in Java that I can show you that used to exist in these older languages. Okay, so I use Objective-C in there a little bit to kind of show you the evolution of things. So we appreciate where we are today. You think about it from the perspective of, I mean, none of us have had to deal with this, but in the old days, you used to have to go out and crank the car to get it to start, right? You know, we've seen that in encyclopedias or something at some point. Okay, so we know that that existed, so we're kind of happy that we don't have to use that today, right? Maybe the more modern approach would be manual versus automatic transmissions. How many of you prefer manual transmissions over an automatic? Just because they're fun? Yeah, you'll grow out of that. When I was in high school, I remember I wanted to do the manual transmission thing because it was fun, right? It's what you want to do. But I don't want to screw around with anything. I want to set the cruise control and take a nap. That's why I'm really excited about these self-driving cars. Isn't that going to be great? It was an interesting debate I was listening to yesterday, talking about because a couple weeks ago Tesla made this announcement that basically in like 6 months or something, all these Tesla vehicles are going to be getting some software update where they're going to drive themselves, at least for interstate driving. I guess that's the easiest autonomous driving situation, is just when you're on the interstate to make sure you don't hit cars, as opposed to dealing with people crossing roads and stuff like that, where a lot more things come into play. I mean, what do you think? Is that going to be problematic, self-driving cars? I mean, it certainly sounds cool, but is it going to be problematic? Are there going to be more accidents or less accidents? They show some of these statistics. There's like 1.5 million people a year are severely injured or killed in car accidents. So it doesn't seem like we can do tons worse, right?
More cars got to be self-driving so they can talk to each other.
Yeah. So that seems like that's going to be the problem, is that transition where you have some cars self-driving and some cars still being driven by the dumb monkeys that are humans, right? So now you have these two guys competing with each other. Once they're all self-driving cars and the cars are all talking to each other, then it's kind of like, you know, bad things can't happen, because when this car has a problem, it tells all the other cars around it to slow down or stop or whatever. But it might be kind of interesting, especially for maybe interstate driving, since that's going to be the thing that comes first. Maybe there'll be even a self-driving lane. You know, now they have the carpool lane. They'll have a self-driving lane where everybody over there is, they're taking naps or playing video games or, I think there's some mock-up for a car that's coming out that doesn't even have a windshield. all the seats just turn inwards. You just sit there with a coffee table and just chill. And at some point, Siri comes over the thing and tells you you've arrived at your destination. And then you find out there was a glitch in Apple Maps and you're out in the middle of nowhere. So we'll see. But that's kind of I think an exciting time was this whole self-driving car thing. So how did we get there? We're talking about manual transmission. So I used to like the manual. Now I want automatic. Now I don't even want to drive. I want to get in and be chauffeured by a robot. That'll be amazing. Wouldn't that be cool? Just tell Siri where you want to go, or if you want your car to be Android driven. Yeah, you add 10 years onto you're going to change your opinion. Driving's fun when you're younger. Then you just want to nap. Like we're getting ready to do this hackathon. I just sent an email out to those of you who are coming to the hackathon to figure out how we're going to drive 17 hours each way and then program for 24 hours in the middle. It's going to be a short weekend. I'm flying because I can't stay up. I can't drive 5 hours straight. I need a nap then. It's ridiculous, but so we'll see. But when you get older, things start breaking. And I'm not that old. Okay, so all of these languages are high-level, strongly typed, object-oriented languages. We go back down here. All of these languages we're talking about here are high-level, loosely typed, interpreted languages. The other ones are compiled languages. So that gets us back to that discussion about the different types of programming languages. Okay, so most of our new languages are either procedural or object-oriented. We could probably just assume that all of our newer languages have some level of object-orientedness to them, whether we actually code in them in an object-oriented way or not. For instance, next semester when we start doing Java stuff, for the first several weeks of the semester, even though Java is a very object-oriented language, we write it as if it's procedural. We don't work with objects hardly at all the first couple of weeks. So all these languages are high level, every one of them. Every one of the languages we use today are high level languages. Some of them are interpreted, some of them are compiled. We might say all the web languages are interpreted. All the PC and mobile languages are compiled. All of our languages are likely object-oriented. Most of them are going to be general purpose. Domain-specific might be like a small language for like a furnace or something like that where somebody has to go in and change the configuration for the furnace where it just has 2 or 3 different functions for turning off, turning on, things like that. That would be a very domain-specific type language. Okay, so in any case, on the client side of things, at the high level, our client understands HTML and JavaScript. Well, in the early days, what did we use this for? Well, the JavaScript, let's just move this stuff over a little bit here. As our web pages started to get more and more complex, we mainly used this client-side programming language, JavaScript, which is an interpreted language, and the actual interpreter is built into the web browser. We use that client-side programming language for mostly validating forms. All right, so the idea here would be if you were filling out like a account registration form, first name, last name, email, username, password, that kind of stuff. Before you use JavaScript, before we started using JavaScript to validate those forms, what would happen is you'd hit submit. That entire form will get posted over the internet to the web server. It would then get processed by the back-end program, whether that was Perl or PHP or whatever. And if you were missing any piece of information, if you forgot to put in your email address or you didn't put in a password, something like that, it would then spit back the answer saying, you forgot to fill out this piece of information. So you try to fill out the form, you send the request, the page reloads in its entirety with either thank you for registering or here's what you didn't fill out. Okay, so it caused the entire page to have to reload plus a whole lot of communication between these 2 points. Well, now we started having our local programming language, JavaScript, check our web form before we submit. So we hit that submit button, and it's going to go through and make sure you filled out at least all the boxes. When you go onto these web pages, a lot of times the boxes have like a little red dot next to it. That means it's required. Okay, so it's going to make sure you fill in all the required information before it ever submits it to this server. Okay, so right off the bat, we have an increased performance because this all happens on that web browser without having to reload the page. This is all happening with the page currently displayed. Okay, so that was the early days of JavaScript. Well, then we decided, you know what? There's more stuff happening on these web pages that currently we're having to reload the entire web page. We're having, the page disappears and then everything downloads another time. Or we take us to a second page that shows us the new content. It might be beneficial for us to have a page where we click on something and only that aspect of the page updates. So in order to do that, we come out with some newer languages. So the first thing that was introduced was something called Ajax. So Ajax is actually something written in JavaScript. So this is a JavaScript library. So nothing really changed in terms of the capabilities of our web browsers. Web browsers still understood HTML and still understood JavaScript. But somebody wrote an Ajax library using JavaScript which allowed certain parts of a web page to just reload, just that part of the page. JavaScript accesses a web page through something called the document object. And you can rewrite portions of the document object with JavaScript. Ajax is a level of abstraction above that, kind of moving towards game salad, not quite at that level of abstraction where you can say, I want to rewrite this very specific part of the program using Ajax. And by putting these hooks in, you can have your page seemingly be dynamic. Things are happening in real time throughout the web page without the entire page having to reload. All right, well, Ajax then had some weaknesses. So rather than just making updates to Ajax, finally somebody said, hey, let's create another library that was inspired by Ajax, does something very similar, but now does it in better ways. So that's where we come into something like Jquery. Okay, so Ajax mainly had a focus on reloading portions of a page. Jquery has that, but also Jquery has libraries for talking directly to a database or a web server. So now what you're having is instead of having your web page when you click on a button, having it go and talk to the server, having PHP go and check some stuff in a database somewhere, ultimately pulling down some information, displaying it to the screen. Now you have all of that happening on the client side. So Jquery, or your web page, the JavaScript in your web page, is now reaching out and talking to databases and different data sources itself, rather than having to get that information through a middleman that is the web server. Okay? Now, why is that beneficial? If we draw a picture of this, let's say we have our web page, and just for our sake of argument, let's say we're getting a Facebook feed. All right, so there's a Facebook feed there that we want to pull in, and then we'll throw put Apache over here. The old way of doing this is our web page would send a request to Apache. Apache would then pass that on to PHP. PHP would then talk to Facebook. And ask Facebook to send us, the current, updated feed, whatever stuff's in on your profile page. All right, so PHP would talk to Facebook. Facebook would then send a response back to PHP. Which then allowed PHP to ultimately deliver its output, which was HTML and JavaScript, which would ultimately get sent back to the web browser. Right? It's a pretty easy model, right? Lots of connections, lots of things talking to other things. Web, hits the web server, which passes it on to PHP, which talks to Facebook, which gets a response from Facebook, which produces the output, which then sends it back to the web browser. All right, so this would be an old model. The newer model for this, using things like jQuery, let's see, we're going to would be this. So now your web browser can talk directly to Facebook, utilizing its client-side JavaScript-based language, jQuery, Ajax, whatever. It's JavaScript. At the end of the day, it's all JavaScript. Okay, so it's a programming language that has capabilities beyond just talking to a web server. So now your web page can talk to Facebook directly and pull in updated feeds. And we've seen that before. We've been on web pages where we actually see the Facebook feed or news ticker, whatever it is, moving, right? The page is actually updating in real time. Early years ago, that was all done through Flash. Well, now we have pages that are HTML5 or even just jQuery supported pages, which are just rewriting portions of the document so it seems like it's alive. Well, this seems a lot better, doesn't it? Well, on the first, in the first case, certainly there's less lines, so it seems better for that. Why else is this model better? Or why might this model be better than this one up here? This one up here works, certainly works. But why is this newer model superior, at least for this type of task? Go ahead.
It's faster.
Okay, why?
Doesn't have to go through as much communication.
True, but if we think about it, if you're the only person using this web server, this communication is going to all happen pretty quick. So I'm not sure you'd notice it being substantially faster, other than the fact that your web page will have to reload. That part will suck. Okay, but it is faster, and part of it has to do with the role of the server here. Go ahead.
There's a lighter load on the server.
Okay, lighter load on the server. How many people are using a web server at the same time? It depends on the web server, but how many Google searches do you think there are simultaneously? 5 or 6? A lot, right? Probably millions of searches are happening at Google at the same time from around the world. So if Google's running Apache, and let's say each one of those searches is bringing back, advertisements. So this is a good example, actually. Okay, so each one's bringing advertisements, and sometimes on Google search result pages, you'll see those ads moving, right? So there's like a ticker of things you might be interested in. I'm not sure if Google works that way, but let's assume it does in this example. If that was done completely through the web server, what that would mean is that Google was handling all of that from its one server. So we're going to say there's 1 million simultaneous users, and all 1 million of those users, their web browsers are having to constantly talk to that web server asking for more information. Probably not going to hold up, even Google. Now, Google probably isn't running just a single computer running Apache. They probably have a warehouse of computers that divide up the labor depending on which server is currently less busy. So they do a division of labor type thing. But regardless of that, it doesn't matter how powerful your server is. If you have enough people trying to use it at the same time, it's going to get bogged down. Okay? How much processing power do you suspect a single Google search takes your computer? If you're the only one, you're the only one using your computer, and you do a quick Google search, probably not that much. 1 million searches take a lot. One search maybe doesn't take that much. Can our one computer handle the different data feeds that are coming into our search results for one person? Yeah, probably. Not even going to seem like it's going to bog down our computer. Do we view our web browsers as being heavyweight applications running on our computers? Like when you open up your web browser, are you ever shutting down your web browser because you think it's taking up too much of your system resources? Or is that the type of thing you kill a video game or something for? You know, we don't really view web browsers as being heavyweight type applications. Okay, so it's not taking up very much of our system resources. So I'm telling you that most of our web pages today are using a communication model similar to this. So it's constantly talking to other sources. Even if you have Chrome minimized, it's still updating the news feeds and stuff like that. Not really hurting your internet connection very much at all, or hurting your computer's performance very much at all. Now, having said that, this is a centralized model where all web browsers rely on the one web server to do all the work. So this would be a centralized model. This guy down here would be a distributed model. We're going to let each individual web browser handle as much of the stuff as possible, only relying on the web server to do things that are absolutely necessary. So for instance, when you go from one page to another page and the page actually reloads, that will involve talking to Apache, getting the response page. Whether that's just a plain Jane HTML document or it's the result of another PHP program producing HTML and JavaScript. Okay? So regardless of that, when a page reloads, whenever you see a web page refresh, that's talking to the web server. When you are sitting on a web page and you're seeing things happen locally on the web page, that's talking to something else, or at least not relying on the web server to do that work. Okay, that's a distributed model. We'll have each web browser take some of the load that used to be put on the web server. That make sense? All right, so we're still going to call this, we'll call this our more modern model. It's a distributed model, and we'll still throw PHP over here. So there's still communication happening between the web browser and the server. But some of the communication that used to exist is now happening only on the client side by talking to something else. Make sense? All right, so we'll call this a more modern approach. But now we have some even newer stuff. So we get back to here. PHP is a pretty old language. Okay, it's been around since some of the early days of the internet. It evolved out of this use of CGI and Perl into a language called PHP. And it was popular for a long time. Its only real competitor was ASP.NET. And that came out several years after PHP had already been out. And this is really Microsoft's competitor. All right, so if you were running Apache, you were probably doing PHP. If you were running Internet Information Server, Microsoft's version, you were probably running ASP.NET. Compatible or comparable type technologies, they're competitors. All right, well now we have a new breed of applications that have come out. So I'm actually going to drop these guys down a little bit here. We're going to kind of put them underneath Ruby on Rails. So Ruby on Rails comes out. And that's kind of fun to say, right? What is Ruby on Rails? I think I asked last time how many of you have heard of it, right? And several of us rose our hands and said, oh yeah, I've heard of Ruby on Rails. What is it? Anybody know anything about it? Well, Ruby is a programming language. Specifically, it is high level, loosely typed, object oriented, interpreted, which as soon as we saw loosely typed, we could have assumed interpreted, right? Let's see, general purpose. Language. That's Ruby. What's the Rails part? Rails is a built-in web server for Ruby. Most documentation will say this is a web framework. Okay, but it's a web server. So what's that Ruby model look like? Let me drag this up here. Well, you have Rails. You have Ruby. You have your web browser. What's the difference? You have your web talking to a web browser, or you have your web browser talking to a web server, which is processing the stuff using PHP, versus you have your web talking to a web server, which is processing stuff using Ruby. Looks like the same thing on the surface, right? Here's the difference. With an older language like PHP, you had to set up this environment. You had to get this environment set up someplace. That is to say, you had to have an Apache server running someplace. You can install it locally on your machine, run it. It would probably be listening on port 80 or port 8080 on your local machine. Then you can install the PHP module for it, make sure that was functioning, and then you can serve PHP pages locally on your computer. All right. If you didn't have that environment set up, you weren't going to be able to see the output of your PHP programs. Nothing was there to receive the request and call the PHP program. Realistically speaking, most people would not have installed Apache and PHP on their local computers. Instead, they would have had to have a server someplace. Maybe they buy a hosting account or something through GoDaddy, pay $5 a month or something like that, where they're getting a Linux operating system or Unix type operating system host, running Apache with the PHP module already installed, and then they can write their code, upload it to the server, and then test it from their local web browser. Bottom line is that creating this development environment wasn't something that took 2 seconds. All right. Once you've done it a bunch of times, if you have worked with an online hosting thing like a GoDaddy or something like that, creating a new account, putting some PHP code up there and getting it running might take less than 10 minutes. It's not the end of the world. But keep in mind that over the years, the people at GoDaddy have streamlined that to the point that you can get an environment up and running fairly quickly. Historically, if you were working at a university like this and you decided, oh, well, we're going to support PHP here on campus, well, that's going to require whoever is the Unix system administrator here on campus, maybe it's Mark Newhouse or something like that, to go in, add some modules to our current web server, configure it, make sure that it's working correctly and all this stuff. And get with his schedule, that might take a couple of weeks to get done. Okay, of actual physical time that we would experience. So this looks the same on paper, but it's not as easy to get set up. Ruby on Rails is a self-contained package. If you want to start writing Ruby on Rails stuff, you can have this running locally on your computer in 5 seconds. So you just start the Rails server, and then you write your Ruby code, and these guys can talk to each other. As soon as you're ready to present this to the real world, to everybody, instead of just you working on it locally on your computer, then what you do is you go ahead and throw the Ruby module onto Apache, and now Apache can process Ruby requests. That makes sense? So we're going to say Rails is lightweight compared to Apache. Apache would be like an enterprise level web server, where Rails would be not an you wouldn't run Google off of Rails. But Rails lets you design something locally and then easily move it over to Apache, because the Apache module for Ruby is actually a Ruby on Rails module. So anything that your program did that talked directly to the Rails server, Apache now knows how to work with. Does that make sense? So you write everything locally. get it working, not having to worry about an external environment or paying somebody $5 a month or anything like that. Everything works here on your computer, and as soon as you're ready to deliver it to the world, you put it out there on a server someplace. Only then do you actually have to create an environment in the cloud. And the reality is there's actually a whole bunch of places that already have Ruby on Rails environments available. A good example, if any of you are interested in trying some of that stuff, is a site called Nitrous.io. And Nitrous.io is cool. It's free for one box, and what you get is so it looks something like this. It basically creates an operating system in the cloud for you, and you access it through your web browser, and you can create one for either Ruby, Node.js, Python is on there, might be a couple other languages, but you can create one operating system box for free. Doesn't cost you anything. So kind of a cool way, and you can actually host all your Ruby applications up there, and now it's available to the entire world if you want it to be. All right, so that's Ruby on Rails. This type of thing. Now notice back here I also had Python and Node.js. Well, let's look at Python. We have our web. Python is the programming language. Well, Python doesn't have an equivalent to Rails. Instead, it has something called, well, it does have an equivalent to Rails. It's called Flask. All right, so this is Python on Flask. So Flask is like a local web server, and then Apache can then process, when you want to finally put it out there to the world, can process your Python stuff. So you can have Python processing your web forms. Now again, remember that all the web side of things here support HTML and JavaScript. Okay, so client side is always HTML and JavaScript on the website. So that means the output of your Ruby or your Python programs will always be this, because the guy who's playing your output, the guy who's going to display the output, is the web browser. Make sense? Now the new kid on the block is this guy called Node.js. Node.js is like saying JavaScript on Node, similar to Python on Flask, similar to Ruby on Rails. Node is the web server. The language you code in is JavaScript. This one actually makes quite a bit of sense. Why? Well, if you are a web developer, so one thing I want you to focus on here is all of these things we've been talking about all deal with the web developer side of the programming language world. Where everything we talked about before this dealt with the desktop, the native application side of the programming language world. If you are a web developer, chances are there's two sides to web development. There's front end, people who make things look good, and then there's the back end, the people who write the PHP or write the Ruby or write the Python. Okay? If you're a web developer, chances are you're going to have some front end skills, making your web pages look good, that kind of crap. That front end person probably already knows JavaScript, because they've been using it as part of their front-end web experience for years. Okay, because your web browser, everything that happens on the client side, is done in terms of HTML and JavaScript. Well, all of a sudden now you've empowered those front-end developers to write the back-end stuff in a language they're already familiar with, JavaScript. So they can do the front end, the client side, and the server side stuff in the exact same language, JavaScript. That makes sense? So Node.js is kind of the new kid on the block. The JS stands for JavaScript. And that's the one. I mean, all three of these are identical type technologies. If you're a Ruby programmer and you want to write Ruby code to process web forms, well, you use Ruby on Rails. If you're a Python programmer and you want to write Python code to process web forms, you use Python along with Flask. If you're a JavaScript programmer and you want to use JavaScript to process your web forms, then you use Node.js. They're all the same model, right? You just choose which language you want. Now, just real quick to wrap it up, because next time I want to show you what we're doing on our next class. We now have all of these different technologies here, all these guys that we painted this picture of over here, right? We go all the way back up to this slide right here, and we have Swift. Now let's just throw just a box over here that just says web stuff. Why does Apple come out with a brand new language after so many years? Well, their competitor, their direct competitor, is Java for Android development. So now they say, hey, if you're still an Android developer because you didn't want to learn Objective-C, hey, take a look at Swift. It looks a whole lot like Java. It's not as intimidating as learning Objective-C from scratch. So come over to the dark side. Similarly, oh, you're a web programmer and you've been using these cross-platform tools, which I want to talk about a little bit next time. So let me actually just create a quick slide for that so we can start with that. Cross-platform tools. If you're one of those guys, rather than using these cross-platform tools, why don't you come and learn Swift, which doesn't look that different from the languages you're already used to? Because Swift looks a lot like an interpreted, loosely typed language. Okay? So really, Swift was not built to make these guys happy. It was built to bring these guys and these guys to the dark side. Make sense? All right, so next class, we'll finish up this discussion, and then we're going to be talking about a tool called Blockly, which is made by Google. It's a graphical programming language. So we're actually going to see syntax without writing syntax. And we're going to start messing with that. Sound good? Yeah. No. You mean this guy down here? This guy? This guy? Yep. I'm just going to switch away from it for a second. Got to stop my